Alright, welcome to a lesson on permutations and combinations. This is going to be a very light touch into permutations and combinations because you'll learn more about this in Algebra 2. So we're just going to kind of introduce it so you can see what it is, get a little familiar with it. So let's get started. So first we need to talk about factorials, because factorials are with both permutations and combinations. And you see this, that in exclamation point, well, that exclamation point is what we call a factorial in math. It's pronounced as in factorial. And here's how factorials work. So we have 8 factorial. What that means is that it's just the simplified version of writing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So what a factorial is just a shorthand of saying we're multiplying everything from that number all the way down to 1 together. So it just saves a lot of space as opposed to writing that all out. Such as 5 factorial is 5 times 4 times 3 times 2 times 1. So that's a factorial. So now let's talk about permutations. Permutations are a type of combination where order matters. So it matters here what's going on, how we pick them. And we have 2 types of permutations we're going to talk about. We're going to talk about repetition. So we can possibly choose the same thing over and over. So like if we were to stick our hand in a jar of coins, we could pull out a nickel and we could pull out another nickel. And that for repetition is n to the r, where n is the things we choose, r is how many are we choosing. No repetition is different. It's like when you're drawing from a deck of cards. You draw out, there's only one 7 of hearts. There's no other repetition of a 7 of hearts. There's just one of them. And we get this np to the r, which is shorthand for the formula n factorial divided by n minus r factorial, where again n is the things we have to choose and r is how many are we choosing. So we're going to take everything we have to choose and we're going to divide all that by the number minus how many we're choosing. Basically we're getting rid of anything that could be repeated. That's why we have this that's why we're using this for no repetition. We're getting rid of that here. So there's a couple examples. So example of repetition. A 3-number lock has the choice of 0 through 9. How many different combinations are there? So you get a bike lock. It's one of those where you can twist and pick the numbers to unlock it. Well, at the factory they have a set order of, hey, this lock has this number first, this number second, this number third. Now that order matters that they're put in. So but what doesn't matter is what number it is. You could have a code that's 111, and that works. It could be 222. That's fine. It could be 122. So you see that there's repetition involved. So what we have to do is we have to use that into the r. So we have to use into the r, where n's how many we have to choose from. So we look, and we're choosing from 0 through 9. So 0 through 9, that is 10 choices. So our n is going to be 10. We have 10 choices of numbers. R is how many we're choosing, and we're choosing 3. So what that becomes is 10 to the 3rd power. And we can figure that out if we were to put that in a calculator, or if you just know what 10 to the 3rd is. You know that that is 1,000. So there are 1,000 possible choices here. Next we have non-repetition. So we're not going to have any repeating, because here we're going to have a bag. It's got all 16 pool balls in it. If you were to choose 4 of them, what are the possibilities here? So how many different possibilities are there? Now this is a no repetition because when we stick our hand in the bag and take a ball out, we're not putting the ball back in. We're just leaving it and sitting it there. So there's no chance for us to repeat that pool ball again. So we have to use that n p to the r. And where our n is our number of choices, so n equals 16, and r is how many we're choosing from, and we're choosing 4. So we get 16 p4, and we recall that we want this n factorial over n minus r factorial. That's the formula. So basically all we're going to do now is plug in our numbers. So we have 16 factorial over 16 minus 4 factorial. Do some simplification. 16 factorial, 12 factorial. And here's the nice thing about this. We don't have to work this all out and then put that in the calculator. We can do some cancellations, because we know that 16 factorial is 16 times 15 times 14 times 13 times 12 times 11, so on and so forth. That 12 factorial is 12 times 11 times 10, so on. Well, what you see here is that, well, on this fraction, this 12 and that 12 are going to reduce. This 11 and that 11 are going to reduce. The 10 and the 10 that would be here would reduce. So basically what's happening is that we're getting rid of everything past that 12. So all we're left with working with is this 16 times 15 times 14 times 13. And that's the only thing that we have to worry about here. So if we were to type 16 times 15 times 14 times 13 in a calculator, we'd get 43,680 choices. So if we had 16 pool balls in a bag and we wanted to pick out 4 of them, there'd be 43,680 possible ways to do that. So that's our answer. Now let's talk about combinations. Combinations are different than permutations in that order does not matter. It doesn't matter which way we pick these things. It just, hey, we're picking them. And we're only going to talk about no repetition with combinations. If we were to talk about with repetition, it would get a lot more difficult. We're not going to cover that here. So for no repetition, the formula is NCR, and that equals n factorial over r factorial times n minus r factorial, where n is still the number of things we have and r is how many we choose. So we have that little bit of a difference here with the r factorial being in the denominator of our fraction. So, an example, a coach must pick 5 starters from a team of 12. How many different starting combinations are there? Now, let's talk about why this is not a permutation, whereas it, as opposed to why it is a combination. You're coaching, you have to pick 5 starters. This is probably for a basketball team. It doesn't matter who you pick first. Go out there and play. 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 As long as we're not considering positions. If we were to say a coach must pick 5 starters and they have to fit these positions, once we pick the person for center, that matters. That order matters now because we can no longer put somebody as the center. We can no longer put someone else. If we fill all the guard positions, it's, hey, order matters. Guards are filled. So here, it doesn't matter. The order says, hey, pick 5 people, tell them to go out there and play. So, we have our NCR, which is that n factorial over r factorial, n minus r factorial. So n is how many we have to choose from. There are 12 players. R is is how many do we need? We need 5. So it is 12CR, which is 12 factorial over, 12CR, 12C5, sorry. So it's 12 factorial over 5 factorial times 12 minus 5 factorial. And that simplifies to 12 factorial over 5 factorial times 7 factorial. Now there's a couple ways we can do this where we reduce, but what I suggest you do is I suggest you use this in your scientific calculator to get our answer. So you get some work with that scientific calculator. So when you type that in the calculator, put 12 factorial, divide 5 factorial times 7 factorial, and make sure that's in parentheses. When you put that in the calculator, you should get 792. So there's 792 starting combinations this coach has if the order does not matter. So go ahead and check, make sure you can put that in your calculator. And this is our lesson on permutations and combinations.